Hi children, how are you? Are you all happy?
Yes, miss. We are happy.
Yes, miss, me too, very happy. Come, let's children, let's do a recap about last week. Listen, I'm going to ask you questions now. So, what did we learn in last week lesson? Miss, we learned about Python classes and objects. What are objects?
So, objects are also known as instance. For example, if we have an object, a car, and its attributes are like the different car models.
Very good. So now tell me what operator is used to combine the class. This a dot operator is used to combine the class. So what is the keyword you use for class? Class space class name. Very good. Okay. Now tell me what is constructor and what is destructor.
Miss, constructor is the one which initializes the program or a function.
This destructor is the one which exit out of the program. Very good children. What is private and public data members? So public data members is described outside a function
and private data members are described inside a function.
Very good children. I am very happy to hear the learnings done by you. Come, let's get into today's lesson. Thank you.
Welcome back, students. And we know all things work together for good to them that love God, to them who are called according to His purpose. Romans 8:28. Good morning. Welcome back to Computer Science class. Today in Computer Science, we are going to see about database concepts. So what is database concepts? Can anyone have a guess what is called as database? Yes, it's used for storing a value. So that is called as database concepts. Okay, so now we are going to see in detail about what is database concepts. So what is database concepts? Can anyone have a guess over here? Yes, as I told you, again it is a storing of value. So that is called as a database concepts. Okay. So now we are going to see them in detail. Okay. So first always comes the introduction. Let's see an introduction for what is called as a database. See here, a database is an organized collection of data generally used to store and access the values. The database system or an application associated with a database. Because of the close relationship between them, the term database is often used casually to refer both database and then DBMS. To manipulate. What is manipulate? To process or calculate the data. See, a school class registers is a database where names are arranged alphabetically. So database have been around since people started recording things. When the people started recording or storing the value, the database concept started. Yes, students. So this is how the database is being working. Now let's get into the next topic. What is the next topic? What is called as data? Can anyone have a guess what is called as data? We already learnt in C programming. Yes, data are raw facts stored in a computer. It may be of any form like text or word or a character. Let's few examples. See few examples. See, it is the pin code number is given, the TPI campus, and then that is secretariat, the short form Chennai, and then College Road. So this is some raw facts as we get the data. It's not arranged in any kind of order. So that is called as the data. So now what are the collection of data that we can see here? See, quantities, numbers, facts, observation, measurements, graphs, and then information. These are the collection of data. Okay. So now we are going to see about the next thing. What is the next thing? It's information. So what is information, children? Can anyone tell me what is information? Yes. Information is a formatted way of data. We are getting some data from the user and aligning it in some formatted way. So that is called as an information. This is called as an information. It will give you some kind of meaning. So with the help of data, we get some information. Correct. This is how the information works. And next we are going to see in detail about the next part. The next part is, as you see the picture, you can guess. Yes, correct. Database. So what is database? Database is a respiratory collection of related data organized in a way that can be easily accessed, managed and updated. So database can be of anything like software or hardware or one sole purpose of storing data. Whether it may be a hardware or a software, it can be used to store data. In the picture you can see different types of database. MySQL is a database and MariaDB is a database, SQL Server is a database, Oracle is a database. So when it connects things or stores the value, this is called as database. Okay. And what's the next thing we are going to see here? The next thing we are going to see here is about DBMS. Can anyone tell me the expansion of DBMS? What is DBMS? Yes, correct. So DBMS is a database management system software. It's designed to store, retrieve, define and then manage data. It is used to store, retrieve, define and then manage data. Correct. Okay. See, the database is here, DBMS and API. These three are called as applications, and then user, and then you have another applications. See how the database concept is working. So they are getting the data from the user and then they are storing the data, they are making a note of it and then they are manipulating it, giving it back to the user. This is how the database concept is working. That is the DBMS, database management system. How they can store the data, retrieve the data and define the data. This is the process how it is working. Okay. So next to DBMS, what's the next topic we are going to see? Yes, the next topic is characteristics of DBMS. So what is characteristics of DBMS? The first one is reduced redundancy. What is reduced redundancy, children? What is redundancy? So you have less number of faults. You will not have more number of faults. You will have less number of faults. What is consistency? The data will be of constant type. And then support multiple user and concurrent access. So what is support multiple users? It can be done by multiple users. Support multiple platforms and multiple users. Data stored into table. Here data is not directly put into the database. It's stored into the table and then it is taken to the database. So query language. What is query language? As I told you in the last slide, it is SQL. What is SQL? Structured query language. From the database, if you want to take only certain things outside. So for example, I have a student database and I want to take only the student name starts with A. So I'm filtering certain things with the help of a query. That is called as query language. And then security. What is called as security? Here DBMS provides a high level of security for the data stored in the database. That is called as security. Transaction. What is transaction? For example, if you are doing the money transaction, you will have a security. So transaction can also be done in the database management system. So reduced redundancy, data consistency, multiple support, data stored into tables, query language, security and then transaction. Correct. These are the characteristics of a database. So what's the next one we are going to see here? Yeah, as the picture says, we are going to see the advantages of DBMS. So what are the advantages of DBMS? Segregation of application programs. So we are filtering the application programs separately. Minimum data duplication. So that is minimum data redundancy or the fault. Easy retrieval of data. You can get the data in a very easy manner. Using what? Yeah, query language. Reduced development time and maintenance. So you have reduced less number of development time and then maintenance is also in a reduced level. These are few advantages of DBMS. Okay. So next we are going to see about the components of DBMS. So what is components of DBMS? There are 4 components. What are they? The first one is hardware, and second is software, third one is user, fourth one is procedure or methods, and the last one is database access language. Okay, so hardware, software, third one is user, procedure methods, access languages. Okay, let's see them. What are they? You all know what is hardware. Yeah, the devices that's attached to the computer is an hardware. Correct. So what is software? The programming or the application that used to run the program is called as the software. For example, Office, Excel, and if you take DBMS, what's the software here? Yeah, SQL. Yes, and then MyDB. Yeah, correct. And then the next thing is user. Who is the user? So the user is the one who inputs the data to the computer. That is called as the user. And then the next one is procedure or the method. So what is procedure or what are the methods? Both remains the same meaning. So we are setting some rules or guidelines to follow the way to the user. So that is called as procedures or methods. And next thing is access languages. So what are access languages? Correct. Access languages is what are the language we are using to get it. It may be of communication language to the computer, like programming languages. So these are the 5 types of components that we are using for DBMS. Okay. So next we get into the next topic. What is the next topic? Database structures. So what is called as the database structure, children? Mainly I told you earlier, the database is data is not directly moved into the database. We have a compiler or some separator over here called as structures, that is the tables. Table is an entire collection of related data in one form. Each row in a table represents a record. Each table column represents a field. So which works each piece or item of data among the records in a specific categories. See example, student name, student number, student age, class, section. These are called as the field. A table is known as relation. These are important objectives, students. A table is known as relation. A row is known as tuple. Tuple we learnt already in the last lesson. And column is known as attribute. Correct. So relation, tuple, and then attribute. Table is known as relation. Row is known as tuple. And a column is known as attribute. Correct. So these are the database structures. See an example over here. Attribute. What is an attribute or a column? The field, student number, name. This is a column. And then row. So for example, this row. Vidya, age 14, student class 10, section B. This is a tuple. And then the next one is the relationship. So table and then relation. So the database, the whole structure is called as the relation. The whole table is called as the table or the relation. Correct. Okay. Now what's the next topic we are going to see? Let's see them. This is a very interesting topic, children. So this is database models. I think you already might have learned database models in your lower classes. I hope in 9th standard, I think. So database models in DBMS. So what are its type? Mainly we are going to see the 5 types that's given in our book. So the first one is the relational model, hierarchical model, and next to the hierarchical model we have the other one. What's the next one? Yes, it is network model. And what's the fourth one? Entity model. And the last one is the object oriented model. These are the 5 types of models. We are going to see them in detail, and it's a very important 5-mark question asked earlier. Data model types in DBMS. Okay, now let's see them in detail now. So what is a relation? Can anyone have a guess what is called as a relation? What is called as a relation? Already I told you it works in the form of tables. The data is stored in tables. What is a relation? See, a relational database model was proposed by who? Yeah, EF code in 1970. So nowadays it's the most widespread data model used for data applications around the world. So now we are using it around the world. The basic structure of data in relational model is tables. All the information related to the particular type is stored in the form of rows in the table. Hence table are known as relation in the relation model. That's why we are telling table as a relation in the relational model. A relation key is an attribute which uniquely identifies a particular tuple. So the relation key identifies the tuple in a table. See how it is working here. So you have an employee database structure. It's taking the customer ID from the first thing and employee ID from the second thing. This is the relationship that we have. And then next, what does it do? It just inputs the data into the employee database to have an reference. So this is how the relational model works. Taking one data from one table, taking another data from another table, combining it and making a relation between the third table. This is how it works. That is the relational model, or you can tell it as relation model. Okay. So now what's the next thing? Yeah, the next thing is about hierarchical model. You should have known about it earlier, students. What is hierarchical model? Okay. Hierarchical model was developed by IBM. That's Information Management System. So in hierarchical model, data is represented in a simple tree-like forms, or you can say it as parent-child relationship. So one child have only one parent, but one parent have many children. This model is mainly used for what purpose? IBM mainframe computers. So this is how the the hierarchical model works. See, they are getting a data and passing it to the node. That is one parent passing it to the children. Okay, that is how the hierarchical model works. Okay, next we are getting into the third one. What's the third one I told you? Correct, the network model. What is network model? Network database is an extension from the hierarchical model. The difference between hierarchical and network data model is, see, there are three differences. In hierarchical model, a child record has only one parent node. Correct. So, but what happens over here? In network model, a child can have many parent node. It represents the data in many to many relationship. So this model is easier and faster to access the data. So parent node has many, and then a child have only one parent in hierarchical model. In network model, a child may have many parent nodes. It represents the data in many to many relationship. In next class, we will see about what is relationships. This model is faster and easier to access the data. Let's see a small picture how the network model works. See, you have a school here and you have library, office and staff room. This child have only one parent, correct? So this library and office and staff room separately have only one parent. For example, this is our school. Assume this is Anita Methodist School. So AMS. Okay. So this is AMS school. We have library. Of course, we have office, and of course, we have staff room. So, but this student, so imagine this student have three parent node. This student can go to library, can go to office, can go to staff room. Okay. This is how the network model takes the data. So, this is an example of the network model. Okay. Now, let's move into the next topic. What's the next topic? I told you. Yes, entity relational model. What is entity, children? In this database, relationships are created by dividing object into entity and its characteristics into attributes. So they are dividing the object into entity and characteristics into attributes. So it was developed when? It was developed by Chen in 1976. This model is used in developing a conceptual design for the database. It's very simple and easy to design logical view of data. The developer can easily understand the system by looking the ER model. So ER model is a very simple one. So what does it do here? Yes, it divides the object into entity and characteristics into attributes. Good. Now let's see an example to make it very clear. See, you have a doctor, a diagnosis taking place for the patient. Doctor have a doctor ID and doctor name, and patient have a ID and then a name. So this is how it is divided. See, these two objects are divided and they are divided into attributes. So this attributes, this characteristics have an attributes. Okay, they are doing a diagnosis and then for the patient. So these are two models which is combined by the diagnosis. So that is how the entity relational model works. The developer can easily understand the system. So once you look at the system, it's very easy for you to capture the details. Good. So now, what's the last model? Correct. The last model is the object model. So what is object model? What is object we saw in the last class? Yeah, object is a thing which can access one parent node. So now let's see what is object model. An object model is a data model based on object-oriented programming. Can I give you example for object-oriented programming? Correct. So Python, what we are learning now is an object-oriented programming. Associating methods with objects that can benefit from class hierarchies. An object-oriented data model is one that extends the individual program space into the world of persistent management and shareability. So what is persistent object management and shareability? So it have an option of sharing the data, shareability. And then the database model is a model based on object-oriented program. An object-oriented data model is one that extends the individual program space into the world of persistent object management and shareability. Okay, let's see an example for object-oriented model. See here, you have a customer and you have a customer name and then you have another name over here and then you have a bank account. You have a address that is in Pune and then another address you have a Delhi over here. This is object-oriented database model. See, you have account, you have address and then you have another address. It is able to access all the data over here. This is object-oriented database model. So we saw about 5 models. What are they? Correct. We'll go from the last. Object model, entity relational model, hierarchical model, network model, relational model. Good children. This is a very important concept in DBMS. I hope you understood the lesson. And that's all for today's class we have. Thank you and stay safe. Have a great day. See you in the next class. Please do go through the lesson. Take up your test on time. Thank you, students.